Welcome to VW 5.5. For today's lesson, we'll be doing word problems, and you're going to need your calculator, so make sure you have that ready. Let's jump right into it. The marketing department at Texas Instruments has found that when certain calculators are sold at a price of P dollars per unit, so let's highlight that, P dollars per unit, the number X of calculators sold is given by the demand equation X equals 21,000 minus 150p. Find a model that expresses the revenue R as a function of the price P. So essentially it's saying we want R equals something here. Now what you have to understand for questions like this, letter A, you have to just know that revenue R, so I'll call it like R of X, the way you generate money is you have to have something you're selling. So we're selling X calculators, or that's your number of calculators, and each calculator would cost P dollars. So your revenue is going to be X times P. And this is something you just have to know just by thinking about the question, right? So your revenue is how much money you're going to bring in. This X is number of calculators sold, and this is your price. So right there is your starting point. Now it says as a function of the price P, what that would mean is in terms of P. Now luckily, if you look at this thing, we have a substitution. X is 21,000 minus 150p. So plug that in. R of X is equal to P, let's plug in for X, 21,000 minus 150p. So now we have our function, and actually this is R of X. I should probably change that to R of P because it's in terms of P. So that's R of P is going to equal negative 150p squared plus 21,000p. And let's highlight that. So there's part A, there's our model. Next one. What price should be used to maximize what price should be used to maximize the revenue? So here's another highlighting moment. You ever see the word maximize? You always highlight that. That means this is a vertex question. So whenever you see the word maximize, maximum, minimum, minimize, that's going to be a vertex. So for part C, let's do that. We're going to find the vertex. So V sub X. So opposite B, negative 21,000 over 2A, 2 times negative 150. Plug that in your calculator, you get 70. And recall that this is your, quote, X value of the vertex. Now in terms of our problem, notice how the X value is right here, that's P. So $70 would be the price per unit. And the question is saying, what unit price should be used to maximize the revenue? Which means, this is it, you found the answer. So I'm going to write therefore, $70 will maximize revenue. Next part, part D, it says what is the max revenue? So for this one, again, you see the word maximum, and it's saying like, what is the max revenue? So what that means is, what is the Y value of the vertex? So we're going to plug in R of, we're going to plug in 70, plug that in your calculator, and you're going to get 735,000. Highlight that. And there's your max revenue. E, how many units are sold at this price? So for E, what I would do is look back at the original equation right here. We know that the revenue is equal to X times P. The question is how many units were sold at this price. So we know a couple things. We know that the max revenue was $735,000. We don't know how many units were sold, but we know that each one of them was sold for $70. There's our nice equation. We'll divide by 70. So X is going to be 10,500, and that's going to be units sold. Okay, now F, graph R. So for this one, on this worksheet, you ever see this like graph, or for part G as well, anything that seems like you need a calculator to do it, just use your calculator. That's why we have a calculator for this particular unit. So open up your HP Prime. If you're in home, you can hit symbol or hit apps and function and type it in to your first function, negative 150x squared plus 21,000x. Hit plot. Now notice it looks like a straight line up here. That's because these numbers are so huge. So we're going to have to zoom out a lot to really see what's happening. So I'm going to keep zooming out, and there we go. There's my parabola. I can start to see it there. And then I'm going to expand it, and there we go. So take a screenshot of this and drop it into your notes, like so. So right there is part G. And I'm going to analyze this for you a little bit. So we found the vertex earlier. The vertex point was 735,000. And then we can see that that is your max revenue, right? Because this y-axis, this is your revenue. So there's our vertex. We can clearly see the 70 and 735,000. Now let's say you had a calculator. You could have actually skipped part C manually. We could have gone here, tap your vertex, and just go menu function extremum. And there it is, 735,000. So notice that's an alternative method to finding the vertex as well. Let's go back. So now it says, what price should TI charge to collect at least 675,000 in revenue? So essentially it's saying, oh, let's fix that. That's not G, that's F. G is saying, what price should they charge to collect at least 675,000? So we're wondering when our function, our revenue function, will collect at least, so greater than or equal to 675,000. So what you're going to do, highlight this thing, plug this thing into your calculator. 675,000. And now we have this nice graph like that. And we're going to find these intersection points by tapping near it. Function, intersection, enter. So there's our first one, 50 and 675,000. And the other one, intersection, there's our other one. I'm going to go back right here. And let's analyze that information. So again, this point was 50, 675,000, and this point was 90, 675,000. We're wondering when we'll collect at least 675,000, which means we want this revenue function to be above that line. So we're really focusing right here. That's the solution. So if you're this company, you would tell them, well, we want to charge between $90 and $50. And that would make sure we earn at least $675,000. Okay, let's go to our next example. A farmer has 2,000 yards of fence to enclose a rectangular field. So let's draw a rectangular field. We'll call this the width, length, width, length. What are the dimensions of the rectangle that encloses the most area? So highlight this most area. Again, you ever see any wording like that, we got to find the vertex every single time. Now we have this 2,000 yards of fence. What you have to realize is that's actually really important. That is going to be your perimeter. So what I can write is I know that 2W plus 2L, that has to equal 2,000, which means W plus L should equal 1,000 if I half everything. And what we're trying to do is maximize area. So I know area is going to be length times width. So what we're going to do is take this equation and solve for a variable. It doesn't matter which one. I'll solve for L. That's 1,000 minus W. I'm going to plug that in right there. So notice what's happening here. Because we're plugging in, we're about to create a quadratic. This is negative W squared plus 1,000 W. And if you have a quadratic, you can find the vertex. So what we just did is we created an area formula given these restrictions. So our vertex, let's find it, opposite B, that's negative 1,000 over 2A, negative 2. That's going to be 500. And remember, that's your x value. So in this case, that's W. Therefore, the width is going to be 500 yards. And if the width is 500 yards, look right here, to subtract it from 1,000, the length must also be 500 yards. So right there, there's your dimensions. Now, if you wanted the max area, simply multiply them together, or you can just plug in 500 right here. The max area would be 250,000 yards squared in the event it asks for that. Now, you also could have used your calculator. You can just simply plug this thing in. Let's go back to our calculator. This would be negative x squared plus 1,000 x and just adjust it so you can see the parabola right there. I'm going to find the extremum, and there it is, 500, 250,000. So let's do a rough sketch so you can see it graphically there as well. $500, 250,000. And the reason it's important to understand the graph is because you can see right there, there is your max area. And it happens when the width equals 500 yards. Okay, so good luck on the word problems. I put a more detailed answer key in case you get stuck, but of course bring your questions to class.